Hello. We have like less than an hour now. My stream broke, so uh, hello, welcome back. If you were here already, you've seen some of this video. This is the one that's actually going to go onto the channel, and we are creating a Slay the Spire style map. You can see on my screen here I've got some generations that I've created using some logic, and so we have these a grid, and we move a number of paths up a unit left and right. And then we end up with these crossovers because sometimes this will go to the right and this will go to the left. So we solve for that by determining if any points that's destination crosses over ours based on a distance. Then we instead go straight up, or we go to their point, or we go straight up, whichever is better. And so I have some logic for that written up. It's through ChatGPT, and it's here on the right. I already started this stream where I created these variables. So we've got num tiers at 15. We've got number of positions, which is 7. The reason this is a tier and position instead of row and column is because I want to actually draw this left and right or up and down. We can actually probably minimize this. We've got paths, which is a array of integers held in an array. So for each path, we'll have all of their destinations, which helps us later when we're doing like travel logic. We can check like where we are and click on an icon to go there. And we started off our logic with an initializer that basically says for the number of paths, which is 6, start off our first entry of this path as a random position along the tier. So our first tier is set up in positions. And then we're going to loop through the number of tiers. We're going to loop through all the paths that we have for each of those tiers. So one tier at a time, we're going to move through. And you can see that logic is just mimicked here. We're going to save out all of our information. Later on, we're going to add a position that's valid to our next position, and then we'll just override our path entry in the array. Here we're determining the safe positions. We're going to do this by going through all of the previously held valid or used transitions, we're going to call it, which is an array that I haven't yet created. It's an array of maps of numbers of tiers. There's of the length number of tiers. And I guess why is it a map? I don't know. So we're going to dig into that. And so for reference, what we're creating is one of these like Cult of the Lamb, Slay the Spire, inscription style maps in Unreal Engine. And I've created some examples based off of these 4 references that I found. So you can take a look at these if you're using Unity or something like that, but there isn't one for Unreal, so we're going to do that. And this is the output, or this is like kind of the output. This is actually, these outputs actually look nicer than my current output. So if we actually look at my current output, scroll all the way down, this is actually my current output. It's it feels a little bit different to the original that we had. So I actually have a version here. I don't know, is it the same? It's kind of the same. I don't think it's too much different. I think the logic is probably the same. So we're just going to create this code block of logic. I might need to ask it some questions because I don't know if I 100% understand. I'm just going to copy this to a notepad. So I have that available. Can I get rid of... Can I just get rid of all of this red lines? I don't know. Oh well. I don't want the red lines. I don't. I'm just going to keep that for later anyway. So welcome to the stream. I've got a checklist here that doesn't matter. It's an old checklist. Let's get rid of that. We know what we're doing here. We're creating this, say, the Spire Map. And so just need to orient my screens a little so that we can see the construction scripts. So we're going to create a new local array that's called L safe positions. Realize I'm using different terminology here. I'm using I and L interchangeably. So this is safe positions. This is current path positions. Current path index. And then we've got candidate positions and the actual safe positions. I don't understand why. Why we have the 3 candidate positions, and then we're saying for every candidate, I guess we're adding to the safe ones, and then that's our chosen position. Sure. So we're adding something to this. Starting off with a local variable called is safe, and we're breaking out of our used transitions. So we have this used transitions, and every entry in used transitions is a tier. It's an array in that tier. So element 0 is for that first tier on the map. As we move, it's going to hold an array of 6 points to begin with, because they'll be random. Let's say it could be 5 points, could be 4 points, and that's just, well, it's generally always going to be 6 entries long, because every path is going to go somewhere, but sometimes they'll get to the same place. So in the use transitions tier, there will always be these 6 entries, and we're going to determine which node is, if we look at this, we're going to determine if we're on this point here, and we're on, let's say we're on this point, we're going to ask the distance for every node here. So we'll get this node, and this node. If there was a transition on any of these, we're going to check if they're going to cross over, so we can deny ourselves moving left or right. It's essentially what we're scripting here. Hey HiveMind, I think I recognize your name. Welcome back. So let's go in here, and we need to create this this sort of map. So f used transition. F used transition. It's going to be, it says it's an array of maps. If I remember correctly. Array of maps. But ultimately, if I open this use transitions up, guess it's not going to let me get rid of this. Let's have a look. Use transitions. I can't get rid of the first entry apparently, so that's that. Now I can. Yeah, okay. So you have to have one variable at minimum. So we're going to have an array of this, which is equal to each tier. We're going to have an array of whatever this becomes. It says it wants to be a map, but that doesn't make sense, because if 2 source destinations equal the same, that it will overwrite the destination. Can we change the used transitions to array of f transition tier transitions? F tier transitions is holding array of vector 2D an array of from position and to position. So that might just make it easier to read. Just like more blueprint friendly, exactly. Could use a vector 2D, which is like a pair of floats, and then just round that to an int and use that as our from and to. But I kind of like it in this case. So we call this from positions to positions. I think, does this work? We don't know which path each one of these actually is, but we do have a list of paths that tells us, like, oh, if I look at 0, I can actually know that that's the red path, green path, blue path if I wanted to. So in here, we're going to have, we actually don't really need it to be a public variable for L used transitions. It's just going to be F transition. Okay. So the tier data is used transitions tier. Get I tier or L tier. Break this. For each candidate in candidates, it says it has a break here, but that's in this one, so that's fine. For I in 0 to from positions. Okay, so we each through this. I think this is the one with the break. Is safe is true. We go through if it is safe. If not, then we come out. If it's not empty, then we do it. Otherwise, the next position is just like straight up. Like there's nowhere safe to go, so we can always go straight up. So I'm just trying to get my head around the nesting of for loops. Let's have a look. We're at 11:44. We don't have too long. We're going to get this logic done, and then we're going to do another episode, probably later today, and just wrap up the visual side. So for int I, tiered data from positions length. I mean, if I could just write this in C++, it would have been quicker maybe, but it's okay. For each candidate and candidate, so safe true. Let's make a boolean. Promote to local variable is safe. there is a point at which this becomes not safe, and then it breaks. And after it's broke, it asks safe positions. Oh, it's renamed it to safe candidates instead of safe positions. Is it done? Is it actually done? It has. Oh, candidate positions, safe positions, that's fine. Not empty. Then we choose a random chosen position. Otherwise, chosen position becomes current position, which means straightforward. Up or right, whichever way we want to draw it. Okay. So as we go through all from positions, we're going to promote this to L source. We're going to have another one that's L destination, which will be the reference to this. The reason I didn't want to use a key value pair is it doesn't make sense. Like, the key map will be broke if there's several sources of the same. I don't know why GPT suggested it. Okay, so then we have a branch, and I'm just going to write the logic out of the way here. The absolute integer candidate. Oh, right, candidate is over here. Wait a minute. L candidate. If the candidate minus the destination. Absolute of that is within one range, basically. If the distance between these two is 1. If it's 0, it doesn't matter. If it's 1 and current position minus source, oops, absolute of that is less than or equal to 1. Within one range or the same. Then safe is false. Okay, so that's yeah. So this is our crossover logic. So what we could do, well, if we do a selector and we random, it's going to give us an error. Okay. Oops. That does this. Move this up. I'm going to wrap this with set chosen position. Okay, and then after this Which loop are we in here? It breaks this for loop. And then asks if it's safe. At the end of the for loop for candidates. So that goes here. Save candidates adds candidate here. As long as it was still safe, which that's, if it's not safe, we don't add it. Cool. And then at the end, if we have a safe position, we use it, and otherwise we go straight up. And then from here, we're going to do one more function. So we want to record the transition. So firstly, use transitions. Set array element. So we want to get current tier. Just set both of these. Essentially need working with structs and arrays is a little bit of a pain because you will end up adding something to this entry here and it won't propagate into the actual setter that you're going to finally set over here, which is then the tier. We do want to size this. Okay, so yeah, it's from positions.add current position or chosen. Oh, from positions add current positions, yes. You could do this and then plug this in, and I don't think it's actually, because this is just like a copy. So you actually need to promote this to a local variable from pos to pos. This is where so let's save this out, or comment this, I should say. This. Set the members, and then we did this. We can test the basic level parts to test whether it works or not. It's the basic. We can test the basic level parts to test whether it works or not. I'm going to draw it. What I can also do is run it, get a debug print, and then plug that into GPT and say, draw this for me, and then we can see if it worked that way before I start trying to draw it with the UMG editor. So this is update used transitions. And then also we have paths, which we were looking at down here. We have chosen position. So we plug that into current paths, and then that goes back into here. By destination to paths. So that should be our whole logic. And so what we can do, as suggested, is like we can debug it. So let's just double check. Initialize use transitions with num tier entries of this. we should definitely promote. Well, I guess we need to initialize used transitions basically from paths. So if we take each path, break that, get the first entry. We didn't actually go anywhere, so there won't be any crossovers to begin with, so maybe it's fine. What we need to do at the very end of all of these loops is just do a print string. And so we'll just wrap this in debug. We're going to go through all used transitions. So this is per tier. Go through each of these. Actually, what we could do is we could just use paths. I think that'd be more appropriate. So let's go through each path and append let's do path index. And then if we break this, each this, we can do path this tier equals, it'll be the index, position equals the element, clean this up a little bit. Okay, so that will print us out our logic. That's in our widget, and so that happens on construct. So we just hit play. We get a access index 1 from use transitions of 0. So let's go and take a look at that. Don't need this, or this. Well, we don't need to open that. Initialize use transitions with the number of tier entries of empty F tier transitions. Okay. Make sure that we do that. Set array element, and it will be number of paths in this case. Make init used transitions. Same error again. Attempted to access index 7 from the used transitions of length 7. I must have missed something along the way, so let's take a look. Here we got use transitions. We do have for int I and 0 tier data from positions.length -1. That's just an each loop through positions, which we've got here. We've got use transitions L. From positions to positions, from to goes in. Cool. So there would be none, it would be safe. And then the L candidate well, it would just be a random. That's fine. Then we try and get current tier. Current tier. That's at 1. Interesting. ChatGPT can just sort me out here so I don't have to read it too long. Blueprint debugger, not what I want. Debug window, such log. Can I just copy that message? No. Let's go to the output log. Whoa. I've done something wrong. Determine what? Why does it need that? And why is it only a problem when it gets to index 7? Also, this this current position might actually go off the chart based off of this, because what if you're at position 0, you'd be asking to go to -1, which okay, so that was annoying. Let's just go select if current position is equal to 0. Then we'll use this array. If it's not, is it equal to num positions? Minus 1, I guess. And if it is, we'll use this array. Thinking, just doing this while I'm thinking, basically. And then it's this. Let's just turn this into something a little bit cleaner. You'll see how this works in a second when I turn this into a function. Like the whole thing should just clean up. Current position. Okay. Oh god, why did it do that? Get candidate positions, and then just make that pure, and then go and clean this up. So I'll just use branches instead of selectors, I think. If it's 0, return. Oops. Return current or current plus 1. Selectors are meh for this case. Okay. If it's not 0, is current equal to the end. Put that in there. If it is equal to the end, then we're going to use, it can always be current basically. This one. And otherwise it could be plus. I like that it didn't guard against that itself originally. I had kind of spotted it in the code. So wait a second. Okay, so I guess we could have done it a different way. What might have been cleaner, in fact. As we loop, we do this. And as we go through the candidates, should ask if candidate is more than or equal to 0 or less than or equal to number positions minus 1. Then it's safe. So it's not safe. Come down here. Actually, just won't add anything there. So that doesn't really matter. It just only goes forward if it's safe. So that's good. I think that's probably cleaner than that get candidate positions function. Okay. So what was our error? Attempted to access index 7 and then 8, 9, 10, 11, 12, 13, 14 of used transitions of length 7. So my question is, why is it getting to that point and then not getting further? So let's just read. It's going to be one of these things where I'm using an array element instead of an index, or an index instead of an element. Okay, so for anyone watching, we're creating this Slay the Spire style map, just as a quick reminder. I've got about 10 minutes, and then I've got to go. So I would like to at least debug this. We've got source and distance. We've got our check logic, which says it's not safe, comes out. If it is still safe, then we're good. So it never broke, so it was good. It falls back to here. We get a random or a same. We come in. We get L tier. In this case, we're going to get 0. Let's hit this on here. We'd like to at least see where we got to. I think it got to this. The tier is 1, but as we start at tier 1. I'm wondering why we're not starting at tier 0. I think we need to initialize this as 0, 0 maybe? Use transitions of length 7 from positions 13. So we've definitely got an incorrect indexing thing going on here. The index should be fine. I want to see what we're plugging in here. Use transitions, 7 of them. That's wrong. Did you already get 7? Oh, right, yeah. Should be numpath -1 to start. Okay. Transitions. Attempted to access the index from use transitions. Show me where. Show me where. Next. Yeah, shouldn't it be this -1? Suppose we are creating a new entry here. Actually, we could just use from to. Think. Yeah, because we're just doing the next section, so we don't actually need this. Okay, so now we've got a big block of logic. So let's go and check what's happening. These are all our paths. Now I just say, use this data to draw the grid. So I can see if my logic works. And this will be the end of the episode, because I need to go and get prepared for a meeting. If this works. You watch it just be like a flat load of lines, or a left aligned load of lines, or something silly like that. It's just not going to work at all. It's taking its time. Wow. I really screwed something up. Either I screwed up writing the debug logic, which is path. No, seems fine. Paths is initialized, yeah. These are the current positions. Should be getting, this should be my tier. All it is it's not it should be initialized to the right length, because I've initialized it right here. Use transitions, it's just a bunch of zeros. Tier is 1 though, and tier 1 would be empty. So I'm guessing I need to initialize that every time. Let's just put valid in. Is this tier valid? Take that data and we'll do go here. Actually, let's go to Notepad first. See what it does. Let's see what it does. It's the moment of your truth. On my shirt. So if we just follow position 65553 0, so that's wrong. 753. Yeah, I don't know. Oh, I know what's going on. Wait, do I? No, I was going to say maybe I'm not clearing it, but I am clearing this, like at the beginning. So current position just starts again. Current path positions is based on the current path that we're looking at. So how do we end up with... Yeah, we're still ending up with a weird chart where we're getting like massive jumps. So if we look at 0, path 0 started at position 6 and ended up jumping to 0. Zero, 1, 2, 3, 4, 5, 6. Sure. 6, 5, 5, 5, 4, 3, 0, 7. So if I read the logic, I would have got my current path positions for the previous tier. Or we could just say last index, essentially. But let's just try last index. And let's say that that was... I think it was 3 and it jumped to 0, right? So it would have been 2, 3, and 4 are valid. As long as they're within range. And as long as we have a tier of data to read. Go through that tier. Check the distance. If it's too far, then it's not safe. But if it was never too far, like there was never a crossover, then we can use this candidate in safe positions. And then as long as safe positions isn't empty, we can use it as a chosen position. Otherwise we use current. So we can only ever add candidate. Understand? We can only ever add candidate, and candidate can only ever be like 3, 4, 5. I don't. It's a bit strange. If I just read that, if I make that print like a little bit longer, like 30 seconds, we could take a look at path 3. So it's like 2, 1, 4. It just jumps to 4 and then back to 2, 1, 4. That shouldn't have been a valid option based on what I'm reading here. Unless the write that happens here is broken. Current path index. Yeah, it's like we're reading a particular path. Weird. So we'll come back to that in another episode. I've got a meeting, so I'll be away for an hour or two. And I'm going to carry on with this afternoon. I want to get to the point where the logic is at least sorted. So see you in the next one. I'll probably do a bit of debugging on this on the offline, and then we could just